Okay, good afternoon to all. Today I am going to discuss about the chapter memory management of operating system. So before going to this chapter, let's look about the articles of the memory management, which is going to discuss memory allocation techniques, under which there is a contiguous memory allocation and the non-contiguous memory allocation. Next, swapping, phasing, segmentation, virtual memory using phasing, demand phasing, page fault handling. So first come to the memory allocation techniques. First, before going to the memory, I would like to say what is the memory. Memory is nothing, it is a storage area on which the data will be stored within the system. And this memory is generally two types. One is your primary memory, or which is known as the main memory, and another one is your secondary memory. So memory consists of a large array of words or bytes, each with its own address. The CPU fetch the instruction from memory according to the value of the program counter, and these instructions may cause additional loading from and storing to specific memory addresses. And memory units is only a stream of memory address. It does not know how they are generated. Program must be brought into memory and placed within a process for it to be run. Then is your input queue, collection of process on the text that waiting to be brought into memory for execution, and user programs go through several steps before running. So these are the source program, compiler or assembler, compile time, object module, other object module, linking editor, then your load module, load time, system library. These are this one. So address binding of instruction and data to memory address can happen at three different stages. One is your compile time. If memory location known a priori or in the prior basis, absolute code can be generated and must recompile code if starting location changes. Example, .com format programs in MS-DOS load time. What is the load time? Now here must generate relocatable code if memory location is not known at compile time. Execution time, binding delayed until runtime. If the process can be moved during its execution from one memory segment to another, need hardware support for address maps, and this is also known as the relocation register. Next come to the logical versus physical address space. The concept of a logical address space that is bound to a separate physical address space is central to proper memory management. Logical address, what do you mean the logical address? Address generated by the CPU, also referred to as virtual address, that is the logical address. That means the address generated by the processor, it is known as the logical address. What is the physical address? The address sent by the memory unit. The set of all logical address generated by a program is a logical address space, and the set of all physical address corresponding to these logical addresses are physical address space. Next come to the logical and physical address are the same in compile time and load time. Now, address binding schemes. Logical, you can say it is also known as the virtual, and physical address differ in execution time, address binding scheme. The runtime mapping from virtual to physical address is done by a hardware device called the Memory Management Unit or MMU. The method requires hardware support slightly different from the hardware configuration. The base register is now the base register here, the relocation register here. The base register is now called a relocation register, and the value in the relocation register is added to every address generated by user process at the time it is sent to the memory. The user program never sees the real physical address. The program can create a pointer to location here 346, store it in memory, manipulates it and compare it to other address. The user program deals with logical address. The memory mapping hardware converts logical address into physical address. The final location of a reference memory address is not determined until the reference is met. Next come to the what is the contiguous memory allocation. In the contiguous memory allocation is basically a method in which a single contiguous section or part of memory is allocated to a process or file needing it. Because of this, all the available memory space resides at the same place together, which means that the freely unused we can say this means that the free unused available memory partition are not distributed in a random fashion here and there across the whole memory space. So contiguous memory allocation means what? Now the memory locations are created contiguously. That means there is no gap, and the data that you can say it is a static memory allocation. Data store or memory is created in a continuous manner. The main memory is a combination of two main portions, one for the operating system and other for the user program. So we can implement or achieve contiguous memory allocation by dividing the memory partition into fixed size partition. Next is your non-contiguous memory allocation. In non-contiguous memory allocation method, it is basically a method on the contrary to contiguous allocation method, allocates the memory space present in different location to the process as per its requirement. As all the available memory space is in a distributed pattern, so the freely available memory space is also scattered here and there. This technique of memory allocation helps to reduce the wastage of memory, which eventually gives rise to internal and external fragmentation. So contiguous memory allocation is a memory allocation where all the memory space are created contiguously. And here's the problem is that suppose you are created 50 locations, but out of that 50 locations only 30 location is allocated. So what about the 20 allocation? And it is not used, and also it is not allocated by the memory to other process because it is already assigned to the one process. So this is the main problem is that their unnecessary space is vacant or not allocated to the other process. Like the example of the array. When you define an array, it is a static allocation. Int A50. Suppose Here is a good example of contiguous allocation. We will discuss in the next class. For today, thank you to all.